Welcome back, everyone. Today we're going to be talking about complex numbers. Complex numbers are going to have the I in it, if you remember from a previous class, and I is defined as the square root of -1. This is called the imaginary unit. Complex numbers are written in a form, this is called standard form, the a plus bi, where a and b are real numbers, and I, again, is defined as we are here. So let's start with some examples of complex numbers. So 5 plus 3i. This is considered the real part. This is considered the imaginary part. Just a quick note on the word imaginary. It's only called an imaginary unit because the person who discovered the square root of -1 and its uses didn't understand it. And so at the time, he called it an imaginary number. But these numbers are very much realistic. They are used all the time in physics and engineering, chemistry, and so on. So just don't let the word imaginary throw it. They think that we're doing something that's only theoretical and not something in the real world. It's very real. Another example would be the -√2 of I. Make sure if you have a radical with the I, you make sure the I is not under the radical. If you put it like into an online homework system under the radical, you'll get marked wrong. And actually all numbers are complex numbers. So even just regular numbers, fractions, decimals, everything, these are all considered pi. Are considered complex numbers. And the way you would write it in standard form is you do 71 plus 0i or something like that. This one could be 0 minus √2i to keep it in our form here. So every real number is actually a complex number, as I just mentioned. The real numbers are a subset of the complex numbers. And so here are some examples. For a, what we can do, we can actually rewrite it. We know that's I, and that's 2, so this becomes 2i. Part B, we have 4 plus 7i plus -6 plus 5i. And basically, when it's plus, we just combine up like terms. When it's minus, you'll have to distribute that negative in. So 4 minus 6 is -2. 7 plus 5 is 12. And you can see we're in that standard form. A in this case is -2, B in this case is 12. Part C is I squared. Now I want to be clear, I squared is square root of -1 squared. We know that the radical and the squared cancel out. So here is our first squaring a number and getting a negative as a result. Complex numbers can be a little strange. All right, let's talk powers of I. We just did this one. Right there. So I is I squared is -1. Now I to the third is I squared times I. We know I squared is -1. So I cubed is -I. I to the fourth is I squared times I squared, which is -1 times -1, or just 1. Now this is a big deal. In fact, every power that's a multiple of 4 just becomes a 1. So for example, if I have I to the fifth, that's I to the fourth times I. That's just 1. 1 times I is just I. That's 1. 1 times I is just I. I to the sixth is I to the fourth times I squared, and I have I squared here. That's just 1. So I squared is -1. I to the seventh is I to the fourth times I to the third. That's just 1. I to the third I have here. -I. I to the eighth. I to the fourth times I to the fourth. 1 times 1 is just 1. Now I want us to see a pattern here. I -1, -I1. I -1, -I1. It's going to cycle like that every time. So how can we use this? Well, notice the multiples of 4 just turn into a 1. So if I have I to the 21st power, that's I to the 20th times I. I to the 20th is a multiple of 4. This turns into a 1. So I to the 21st is just I. Now this one was easy because I knew that I knew 20 was multiple of 4. What if I have a much larger number? I to the 237th power. Well, what I can do is I can actually just divide that out by 4. And the key here is that remainder. That means that this literally turns into I to the first power. If that was a 2, it'd be I to the second power, and then I would simplify it. If that was a 3, and that would be I to the third power. I would put negative I. If it was 0, that means it's multiple of 4. So it's just a 1. We need to practice with those. So just divide by 4. So in other words, if I were to write this out, I would write it as I to the 4th times I to the 4th times I to the 4th times, and then I would have 1 I left over, and all 59 of those I to the 4th powers all turn into a 1. May need to pause the video to think on that one. All right, next up, we're going to multiply. I'm just going to do regular FOIL. Now these two middle terms I can combine up. This here, we know I to the second power, once again, is negative 1. So that becomes minus 8. And negative 35 minus 8, negative 43. And notice I'm still in A plus BI form. That's why we don't write the I first, because we want to keep it in our standard form. And next up, so now we're going to multiply. These are called conjugates. Let's talk about that for a second. That's going to be important here in just a moment. Meaning I'm adding and subtracting, or I'm multiplying. The numbers are the same, except one is minus, one is plus. And if you recall, there's an old rule called the difference of squares. And here are our conjugates, where one is minus and one is plus. That's exactly what we have here. And we're going to utilize that. A in this case is going to be the 3. B in this case is going to be the 4. 4i, I should say. So this becomes 3 squared, a squared, minus 4i squared. This becomes 9 minus 16i squared. But as we recall, I squared is negative 1. Now, one of the advantages of multiplying conjugates is all the I terms are gone. And that's going to be very useful for us here in just a moment. All right. So I'm going to use this rule, this next part. This is a perfect square rule for part A. Where A in this case is 5, B in this case is negative 3i. So here we go. This becomes plus, because I'm squaring a negative, 9i squared. Remember, that becomes a -1, so that's going to make that -9. Which gives us, I think that's 16 minus 30i. Cool. Notice again, I'm in standard form. Now part b is raised to the third power. And if we recall, 5 minus 3i to the second power times 5 minus 3i is how I could break this up. And I'm going to actually use my previous answer to multiply this out. Five times 16 is 80. 3 times 16 is 48i. Negative 30i times 5, that is minus 150i. 30i times 3i is going to be plus 90i squared. I'm going to combine up my like terms. Now that I squared is going to make that minus 90. Minus negative 48 minus 150. Minus 90. This gives me negative 10 minus 198i. Again, we are in standard form here. A plus bi. A in this case would be, not that A, this A is negative 10. B in this case is negative 198. All right, now we are going to use conjugates again. Just a quick recap. That's when they're the same, but one's minus, one's plus. And I'm going to multiply the top and bottom by the conjugate of the denominator in this case. So if I have 7 plus 2i, its conjugate, 7 minus 2i. Has to be the opposite. Up top, I'm going to FOIL. So that's 28 minus 8i plus 7i minus 2i squared over, and now I'm going to use, again, the difference of squares. A squared minus b squared is what I'm going to get. So a in this case is 7. B in this case is 2i. Quite a few moving pieces for this one. I'm going to combine it by like terms here. That I squared is going to become a -1, so that's going to make that a plus 2. And I'm going to go ahead and square these down here. So a lot going on with this one. Up top, I'm going to combine it by like terms. Down below, that I squared becomes a -1, so that makes that plus 4. Ordinand plus 4 is 53. Now, I'm not in standard form, the a plus bi form, but I can break this up like this. And this way, a, pardon me, for the standard form is a 30 over 53. The b in this case is a -1 over 53. All right, we are to the last part here. All right, so for part A, we're gonna use the quadratic formula. And yeah, so just to recall, All right, so part A. A in the formula is 1, B is 2, C is 7. So here we have a negative under the radical, which is okay. I'm going to go ahead and simplify that radical. Now this is 2I root 6 over 2. And I'm going to factor out a 2 and reduce it. And that's going to give me negative 1 plus or minus root 6I. And I want to be really careful with this. Often I'll write the I in front so that there's no confusion that that I is not under the radical. Part B. We have x cubed plus 27 equals 0. If you remember, this is a sum of two cubes. This is going to factor to x plus 3, x squared plus minus 3x plus 9 equals 0. We can see x plus 3 equals 0. So there we have a real solution. However, when we run into this part, x squared minus 3x plus 9 equals 0, we have a quadratic. So once again, I'm going to use the quadratic formula. A in this case is 1, B is negative 3, and C is 9. And that is going to simplify to 3 plus and minus 3I root 3 over 2. Now you'll notice I didn't quite write this in standard form, which is okay. When we're dealing with the I and the radicals and all that kind of stuff, this is actually a much more clear way of writing that, in my opinion. Part C. So here we have x squared plus 16 equals 0. X squared equals negative 16. X equals plus or minus 4I. So that one's not so. There's a way to do that by factoring as well, but I think this is a little easier. All right, part D. Minus 5x squared minus 6 equals 0. Now, I could use a quadratic formula on this, but there's really no need. This one factors. So this is x squared equals 6. X squared equals negative 1. X equals plus minus root 6. Now, normally we would be afraid of something like this, but now that we know complex numbers, not so much. So x equals plus or minus root negative 1, which means x equals plus or minus I. So we actually have 4 solutions. In fact, I'm going to write them out so we can explicitly see them. Root 6, negative root 6, I, negative I. 4 solutions. Complex numbers, not so bad.